Yeah, hi guys. This is Eric. It's been a it's been a while since I made any videos for my YouTube channel. Um, it's not really like even an official channel. I just make some videos when some interesting ideas just pop into my head. And um, one thing that just has been kind of pushing me to make a video um, is something very interesting that I just kind of started um, forming in my this crazy noggin of mine, and it's that light um, creates matter. Yeah, and it's all theoretical, of course. These ideas just kind of pop into my head. Just from just making observations and just listening to videos once in a while and uh, oh, another thing that's really kind of kept me from making videos was that I was being barraged. Once I had made my first, I think it was like what, 6 videos last time. um, I was being barraged by the algorithm of this platform, by all these physics videos, which I really just didn't have too much time to watch. Uh, you know, I did watch a few of them, but it was just too much information. And, um, when you've got like kids and we just moved into this new area, and anyway, there's a lot of things to fix. Got a son that's into baseball, trying to figure out certain aspects of the game for him, and um, also I've got a daughter trying to get into university. She was accepted, by the way. Congratulations to her. Um, but anyway, this whole idea about light creating matter just started just really keeping me up at night, and I just had to make this video. And I know my videos tend to be like very dry, boring, and a friend of mine was like, geez, I was like falling asleep through your lecture that you give. So I'm sorry about that, but I like I said before, I don't have a professional a video maker, or I don't have any knowledge of being able to do that. My daughter could do it, but she's so busy studying, and I don't want to bother her. I presented her with the idea one time. She was like, "Hey, Dad," you know how it goes. But anyway, how does light? How could light create matter? Well, if you remember in my other videos, I was talking about how we live in a false vacuum. I'm pretty convinced of that now. It was kind of like this idea that was I was kind of I think in my first video I was talking about the split blind experiment where they shot like these electrons through this. You guys know what it is if you've done any kind of studies on physics. And you end up, instead of with these, if you fire this electron uh, beam through one particle at a time, you would expect these two lines forming, but you end up with this interference pattern. And I explained the whole thing with my other video. If you want to watch that, um, to get an idea of what it is uh, I explained what different scenarios could be happening to cause that. Um, I don't want to go through the whole thing again, but just watch that video if you can just bear the boringness of it. But anyway, um, getting back to how light creates matter. Um, another thing I brought up that a lecturist. He was a very famous PhD physicist. He's one of the project or the, I guess you could call it a think tank leader in Berkeley. He was talking. He totally confirmed like my suspicion. I said, this energy, this matter, the quantum behaves like fluvial dynamics, and fluvial, that implies water. So it behaves somewhat like water, and you know, in his lecture, you can hear him say, "Well, yeah, it's very similar to fluvial dynamics." He uses the same word, and I was like, "Oh, okay, well, there you go." But anyway, uh, um, what I wanted to say is, okay, going back to, oh my gosh, I'm sorry, I don't like practice what I'm gonna say. I'm just, rambling as I go on, without any kind of like cue cards or too much notes. But excuse me for any kind of pauses or whatever. But um, okay, so how could light um, form matter? Um, okay, so with this idea of living in a false vacuum, and uh, basically we live in a medium, a universe made of like infinitely small particles. We'll call them like ISPs, ISP, infinitely small particles right here, right? And I think they're actually smaller than, they're so infinitely small, I would say they're even smaller than strings, as string theorists calls. And I'll tell you like what's up with that in a second. Uh, in fluvial dynamics, like I mean, you guys have heard of freak waves and how they form, right? If you listen to how they form, is you get like a one wave pattern that could form on this side, right? And then another wave that's kind of like coming in an interference pattern. And then it clashes and creates basically uh, a square wave. They call it a square wave because it's just a freak wave. Like a square wave is like this. And um, and if you see what I'm trying to get at, you're probably like, oh, I see what he's trying to say. Um, um, Sine waves are like this. The waveform, as they call it goes like this, right? These are normal waves. But when you have a freak wave, it's called a square wave. It just pops up out of nowhere from interference of these fluvial dynamics. Well, okay, now if you can understand what I said in my other videos, that these um, particles, when you shoot them through, because we live in a this false vacuum, what we quantify as electrons, these are like what would you say, a mathematical what did I call them? Mathematical constructs to basically quantify um, uh, emergent particles that have emerged from this sea of infinitely small particles, the ISPs, as I said up there. But anyway, um, this interference pattern, if you notice, these are not sine waves. You could say these are square waves in the pattern that they form because of the interference pattern caused by shooting electrons through this double blind experiment. Okay, that being said, um, what happens is you get this gigantic wave, in the middle of the ocean. They're called freak waves, and they stand up to be like 100 feet high, and you've heard of, like, ocean liners getting hit by them. Some were like 80 feet tall, 100 feet tall. Um, and they can even be caused by earthquakes and whatever. But we're gonna strictly stick with how just the fluvial dynamics plays just through interference waves causing these square wave patterns to form these. So anyway, when a light let me see. Okay, so let me I'm sorry, I'm just so jittery and nervous when I do these videos. I'm not a great speaker at all, but let's say we have a, this is like water. This is all water, and you shoot a, high velocity packet of energy through here, and this packet of energy is, well, okay, I'll demonstrate it by like what a bullet does. You shoot a bullet into a pool of water, a medium. What happens? You get an incredible amount of amplitude that is right in front of the bullet. It's like that. Instead of like a little smooth wave of energy in front of it, you get this high amplitude wave, and you can get all this insane compression that is right in front of the bullet, and it also parts. You can see it creates like this, like a tunnel, and it parts the water. And what's happening too is it's called cavitation, and the cavitation is when like, for instance, like a propeller. It's the propeller of a boat or actually a nuclear submarine. They try to prevent cavitation, and cavitation is the friction. The tip of the blades, they start spinning so fast in the water, it starts separating the gases. Especially, I think it's is it the hydrogen or oxygen? Anyway, it starts creating bubbles, and these bubbles create noise, and you don't want noise in a nuclear submarine or any kind of submarine, and because the enemy will detect you underwater with their sonar, but anyway, this is also high amplitude waveforms happening in the direction of which way the propeller's traveling, and you end up with this cavitation occurring. But anyway, with if you can imagine this bullet as being a photon, as they call it, right? It's just a packet of energy, the same as a bullet, you could say. And this whole tube of cavitation, or whatever you want to call it, parting of the water. This is, if you look at this, you could like make these like cross-hatched, what do you call it? It's like what do they call it? A toroidal tube. It's a toroidal tube. And what's happening really is, in this packet of energy that's traveling through the water, it's propagating quantum eddies, and it's pushing away from this packet of energy, the particles of, if you think in terms of fluvial again, you could say it's pushing away the water, or is pushing away the ISPs, the infinitely small particles, and it creates this high amplitude waveform, and it stops at a certain point depending on the velocity, energy, blah blah blah. But anyway, this is where you get the um, what do you call it? So, the toroidal. Um, I don't know if you could say it in terms of like if this were, oh my goodness, if this were like a electrical wiring, right? And light energy, which is what electrical energy basically is, uh, or at least that's what. I'm getting a little lost here. Well, anyway, I think you guys understand what I'm saying. This energy is this energy. They found out electrical energy is actually light energy, and it's being transferred, conducted through um, this conductor, right? And it's the same thing as you could say like light energy traveling through copper wiring or whatever. And that's another subject I want to speak about in the future is superconductance and what causes like superconduction. They already have a mainline theory about that, but that's a whole nother subject. But that's a future video I wanted to make. Um, and I think there's still a open Nobel Prize for whoever figures out, what's really going on with superconductors. But anyway, going back to this, um, these energy packets or light photons, they'll create this toroidal, pathway, and they also, according to this one video I saw, they they said it was electrons, but I think it's more than just electrons. Electrons, like I said, is just a mathematical construct, and they start spinning off, and they create these like eddies, uh, and maybe it's within this toroidal um, tube, you could say, of energy that's being created. It's a pathway. Some people call it a magnetic field. You can call it whatever you want, but just for my argument's sake, um, we'll just say, oh my goodness, I'm forgetting my place. Oh my gosh. Oh yeah, 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 yeah. I'm sorry. Oh my goodness. Okay, so anyway, let me try to regather my whole point here. I'm losing myself. Yeah, so these eddies, um, you know, they propagate this way, and just keep that in mind. Or they're within this like barrier, or that's what I was trying to say. Oh my goodness. That's why I really don't like making these videos. They get a little too much for me. Um, but anyway, so what happens is these uh, light waves. Okay. So when you hear my explanation about why you get uh, these are basically square waves. What happens is that the light waves, photons, they create interference patterns because they're pushing in front of the high um, amplitude waves in front of them. So basically, you could say like these light waves are going, is pushing high amplitude waveforms in front of it. Okay, that's what I was trying to say. So, excuse me. I can't even speak right. Um, I'm just getting so excited with this. So when does these, uh, you know, energy, high amplitude waveforms are in front of it. And then let's say you have like another source of light that comes this way, right? And then another source that comes this way. And maybe it's only two sources, but I'm just going to use three. Well, what happens to the infinitely small particles that are like here? Well, they get compressed together. And compression is an attribute of like of gravity. And so these ISPs are compressed together, and there's some sort of like you could say quantum gravity forming there. So when you have quantum gravity forming there, well, then you get these well, it's like ta-da, you get these strings of matter. You get these strings of matter, and from this interference pattern created by multiple light sources, and I don't know how much the strength would have to be. I'll leave that up to the real physicists to calculate. If this idea sounds correct to them, then they can figure that out. I'm just putting this out there freely. But yeah, it's if you looked at this from a different angle, it would just look like just like a string. And the string is made up of all these like little like particles, and these particles, like I said before, they're not detectable yet with the sensors we have. They're too clumsy what we have, even though like we're making city-sized colliders. I think some of the videos that I like, barely had time to see was they were saying like some of them would have to be the size of the solar system to really be able to detect these infinitely small particles. And maybe it's dark matter itself. I remember Neil deGrasse saying like, oh, we don't even know what dark matter is really made out of. But I think really because we live in a medium, and then I said this matter is what forms gravity. At the quantum level, it's an emergent gravity basically. And interestingly, I have to mention, I think I was watching Michio Kaku YouTube thing, and he was saying how like there's a new theory called emergent gravity, and I'm like, isn't that interesting? Well, uh, because I kept talking about like my theory was called multiverse leak down theory / emergent theory of matter. And anyway, this is how I'm saying matter forms. It's through interference patterns of light. I don't know what magnitude of light and what frequency and strength it would have to be, but the general idea you guys are, I'm sure, understanding what I'm saying. But anyway, after it compresses all this infinitely small particles into a string, just like proteins when they form into, protein constructs like the exoskeleton of like a cell, or any kind of like proteins that are necessary for life to function. They have to bend, and these strings of particles that form, they curl up. And I said that in the previous video that they must swirl up into like a infinitely small like spherical shape, and these strings of particles, they start bending in on themselves, and they basically create their own little vortex. and basically they collapse, you know, um, in on themselves and become, well, tiny particles that we know as these quantum infinitely small particles like oh my goodness, what particle did they just discover? I just made an entire video that um, the Higgs particle. I'm sorry, I'm like forgetting. It's been a while, so yeah, I had to recall that. And then you uh, and how does this vortex occur? Well, again, light. Remember these electrons that spin off. The video I watched, they said it creates these eddies of electrons that are spinning off. And well, if you have, you know, a string particle, that's a candidate for an electron to basically get it caught up into, an eddy, which is they tend to spin off like this. If you, I had quite a few engineering friends that went to some very prestigious colleges and or universities, and they were telling me a little bit about like uh, aerodynamics, and when you have a car, that is traveling through the air, uh, and they're testing for the drag coefficient, and it's got a little tail in the back, like this. uh, if it's aerodynamic, you'll end up, and this is with aircraft too, I believe, but mostly with cars. You'll get these eddies that come off, like you know. Basically, if this was the car, you would see the eddies coming off like this on the backside, really. But anyway, getting off a little topic there about cars, but uh, the eddy of electrons, and maybe it's something even beyond electrons. They literally curl up the string matter that has formed through this square wave I was talking about, which forms through this interference pattern. And you can clearly see that this is maybe creating square waves at a quantum level. I'm not talking about these interference patterns that appear on the wall. These are strings in string theory. So anyway, that's my take on that. I don't know how else I could explain how light creates matter. I didn't want to make this video too long. They but also I wanted to touch on a few mistakes I made in my earlier videos. I think I said like the universe was like 40 billion years old or something like that. No, it's like 14.7 or something like that. 14.2 is it? It's somewhere like little past 14 billion years, and our solar system is only 4 point, roughly 4.5, 4.4, no, 4.7 billion years, something like that. So, my apologies for any kind of like I'm not trying to deliberately put confuse people or put misinformation out there. Uh, um, I'm not perfect in my discussions. This is all theoretical stuff I'm presenting. What else? What else did I want to talk about? And I wasn't really happy with my time, to like trying to define time. I was really getting more into the like convoluted description of his more of his attributes, and like what could be going on like in the bigger picture. Um, so basically, I want to like make a short video on just a concise definition of time, and that, and what else I have on my little couple little notes. The age of the universe, explanation of time. Yeah. So I wanted to do a thing about explanation of time. I would like to get into a little bit about superconductor conductance, and Uh, and I think that's it. So hopefully you found this interesting and insightful. If you could just like if you use any of my ideas, at least just give me a mention or something, and some likes on my videos. That would be very nice. If in the future, if I put up a thing for a PayPal donation, that would be also very, very kind. Um, I know everybody's got it pretty tough out there, but if you found my stuff insightful and interesting, at least, then that'd be very, very nice of you to do. Hit the like and or you can even make a comment saying, "Oh well, I think your ideas are complete nonsense," or whatever. I can handle criticism. I've got a pretty decent sense of humor, so you know, I can handle a lot of comments, whatever. Um, Also, in the future, I just like to like make videos about like my my family. It's some real interesting things there. I found out like I have Dutch ancestry. It's my father's mother's side. They actually, um, my grandmother's aunt was married to the first ambassador, Dutch ambassador to all of Korea. Korea was not divided at the time, so yeah, it is totally interesting, and I actually have paperwork from that. And this right here is his Dutch blanket box. You see right there, and um, I did get like um, some of his estate passed on to me, and it's really interesting. So I've had relatives. I'm pretty sure that work for Dutch for the Dutch government, and I wanted to do maybe a video about some interesting people in my family that were very historical. Um, I mean, just from just not only for the public, but for especially my family, my kids, so they could get an idea of their heritage and their history, family history. Um, anyway, thank you for listening to my rambling, and I'll soon make another video, hopefully, explaining, making a more concise video about time, which is already in my head. I just haven't got around to it. I've had it for like over like a year because I wasn't happy with the I just started rambling really fast towards the end of that one video. I think the last one, and you were probably like, "What? Like, why is he like talking all crazy fast?" Because people are saying your videos are way too long. They're going into like almost an hour. But anyway, thank you again for listening to my ideas, and hope to see you on the next one. Thank you very much.